Okay, our project is a integrated industrial control and data acquisition system for industrial processes, and our sponsor is Accutech Precision Aerospace. So what our system needs to be able to do is to be able to log operational data, send remote error messages to operators or anyone else who would need it, and it has to be capable of industrial control. In order to be able to do that, you usually need a PLC and some sort of computer. In our example, we have a Raspberry Pi. Raspberry Pis tend to operate on 3.3 volts, while most industrial equipment, such as PLCs, operate at 24 volts. If you try to connect those directly to each other, the Raspberry Pi would catch on fire and burn and explode because it is not rated for 24 volts. So for our situation, we needed to design a PCB to be able to interface between the two. This PCB runs on solid-state relays primarily, which allows us to step between the 3.3 volts and 24 volts to allow these two to communicate over their I/O. Otherwise, this would not be possible. In a larger system, like the system that we're going to use to demonstrate, there's multiple different components involved. An industrial machine will be made up of multiple sensors, gauges, conveyor belts, what have you, that will need to communicate over both Ethernet for certain aspects and over I/O for some other aspects. Some will need to go through the PLC, others may need to go directly to the Pi. This is where our PCB comes in because it allows to be able to step between the different voltages. For the data logging aspect of our project, the Raspberry Pi is capable of collecting any operational data for the machine and logging it onto a CSV file, which is openable in Excel. This CSV file is automatically stored on any flash drive plugged into any of the USB ports at the time of the machine starting. And this is what the logging looks like. If in any situation comms are lost specifically over Ethernet, there is stuff in place for notifying operators if something went wrong. The Raspberry Pi, when it notices that it loses Ethernet connection to the PLC, will send a text message over Wi-Fi internet to any number that you have specified, and it will alert them within like 30 seconds that comms have been lost. Here is some videos of our system in action.
All right.